So the electromagnetic radiation, what are electromagnetic radiation? The electromagnetic radiation means the radiations which can pass through vacuum does not require a medium to travel. But why specifically we call them as electromagnetic? The term electromagnetic is actually these radiations consist of two fields. One is electric, another one is a magnetic. It's not the particles, it's just the two fields are there. In these waves, there are two fields present. One is the electric field, another one is a magnetic field, and both fields are perpendicular to each other. So if you want to show how the electromagnetic waves, like we want to draw the electromagnetic waves, so any one of them you can draw first. It's a 3D structure. So we have these axes. So if I draw the electric field first, so this is representing the electric field. And it is a variable electric field. Continuously, the electric field changes. And the change in electric field produces a magnetic field. So this is representing a magnetic field, the red one. And both of them are 90° to each other, perpendicular to each other. So all these electromagnetic waves, even a radio, micro, infra, visible, ultra, X-rays, gamma rays, ultraviolet, X-rays, gamma rays, all these radiation consist of electric and the magnetic field, which are perpendicular to each other. And this is a direction of the wave, direction in which the wave travel. But what is the difference between these waves? The difference between these waves is the frequency. Like when you compare a radio wave, the radio wave will have a longer frequency, means the longer length a change for electric field as compared to that of a gamma, which is having a shorter wavelength or higher frequency or more change in electric and magnetic field per second. So what is actually the idea of electromagnetic radiation? The idea of the electromagnetic radiation is that the change in electric and a magnetic field, this electric and magnetic field we call electromagnetic waves. And all these electromagnetic wave, what is the speed in vacuum or in air also? It is 3 exponent 8 meters per second. And later in the topic, you will learn about light. Light is having a dual nature. Sometimes light is electric. What is the wavelength here? Wavelength is a distance between the two successive crests or two successive troughs. So when I take this length here, I will call that as a wavelength. So this wavelength is different from different waves. If it is a radio wave, the wavelength will be longer. But if it is a gamma rays, then the wavelength will be shorter. So the only difference between these electromagnetic radiation is the wavelength. And related to wavelength is the frequency. But they all have the same speed, which is 3 exponent 8 meters per second. Is it clear? The concept of electromagnetic radiation and the electric and the magnetic field, the variation. So electric and magnetic fields are perpendicular to each other. So if we want to produce electric or a magnetic field or electromagnetic radiation, so example, this is the sun. On the surface of the sun, there is a nuclear fusion, like hydrogen atoms combine and it is forming helium. And the temperature increases. So as the increase in temperature, the atoms vibrate. When these atoms vibrate, what these atoms consist of? these atoms consist of, because if I talk about hydrogen, this atom consists of one proton and one electron. So there is the example hydrogen atom which is having one proton and one electron. Because of the nuclear fusion, it releases energy and these hydrogen atoms vibrate. Proton and electrons are charged particles. So when charged particles vibrate, what they will produce electromagnetic waves. Whenever any charged particle vibrate, it will produce electromagnetic waves. So as a result, what will happen? Because the atoms, the hydrogen atoms or other atoms are vibrating, which produce electromagnetic waves. So, and when electromagnetic waves are produced, it depends on the number of vibration per second. If it is vibrating, like if the wavelength is between 400 nanometers to 700 nanometers, 400 nanometers actually violet and 700 nanometers red. So if the frequency of if the wavelength which is produced by this vibration, if it is 400 nanometer to 700 nanometer, and I'm observing this on the earth, then I can see this because this is in a visible range. So we can detect, our eye can detect. But what if the wavelength is longer than this, like the wavelength which is produced is more than 700? So more than 700 means it will be infrared. So if it is infrared, what will happen? We will feel this on the skin because on our skin, like we have water molecules. So when the water molecules or the molecules of this on the skin exposed to the heat radiation, the particles of the skin vibrate and it produces a sensation of the heat. So we cannot see infra, but our skin can detect that infrared radiations. But if the wavelength is shorter than 400 nanometer, if the wavelength of a wave is shorter than 400 nanometer, then what will be? It will be the UV or ultraviolet radiation. Because we have visible, we have after visible UV and before visible it is infrared. So from 400 nanometer to 700 nanometer is the part of the spectrum which our eye is sensitive, like we can detect. But if the wavelength is shorter than 400, we cannot detect. If the wavelength is longer than 700, we cannot detect. So only range which our eye is sensitive, the only range our eye is sensitive, that is 400 nanometer to 700 nanometer. So infrared cannot be detected by the eye, the UV cannot be detected by the eye. So because of the nuclear fusion, the atoms, the hydrogen atoms are vibrating. When the atom vibrate, whenever any charged particle vibrate, it will produce electromagnetic radiation. But the production of the electromagnetic radiation depends on how many times this charged particle will vibrate or what is the wavelength associated with this vibration. So we have the order, like example, if it is vibrating, let's say this one, the table. So if it is vibrating 10 exponent 3 to 10 exponent 6 means like kilo to mega, what kind of wave it will have? Like this many vibration in 1 second. So it will produce a radio wave. But it is if it is vibrating 10 exponent 20 to 24, what kind of wave it will produce? It will produce gamma rays. So the vibration of the charged particle is actually the source of the electromagnetic radiations. Is it clear, the concept of the production of electromagnetic radiation? Anyone having a doubt or a question till this point? Same way, like example, thermal sensors, like in our body, like we eat food, we take in chemical energy, and that chemical energy turn into the heat energy and we use it for a kinetic. But that the vibration in our like there's a vibration of the particles in our body. As a result of this vibration of the charged particle, we are producing heat radiation, infrared radiation, and that's how the thermal sensors detect. If our body temperature is high, we produce a greater amount, greater intensity of the heat radiation. Anyone having a doubt or a question about the production of these electromagnetic radiation? Then the polarization. Polarization is also a property of a wave, but this polarization is actually a property which is only associated with a transverse wave. Longitudinal waves cannot be polarized. What is the meaning of the term polarization? Say we have a source. Example, let's take example of a light. Say example, polarization, but remember one thing, polarization happen for all kind of waves, electromagnetic as all kind of transverse waves, but not for longitudinal. But we are taking just example of the light. Example, so this is a fluorescent light, or you can also say a tube light. What a tube light consists of? It consists of helium, inert gases there, helium and argon. When we switch on, like when we supply, it produces an alternating electric field. As a result of alternating electric field, these helium atoms start to vibrate. So when these helium atoms start to vibrate, some are vibrating horizontally, some are vibrating vertically, some are vibrating at diagonal at an angle to the horizontal. So as a result, when the electromagnetic radiations are produced, some electromagnetic radiation, I'm just taking one field, either electric or a magnetic. So I'm just taking electric field. Some produce electric field in this manner. Some are vibrating, so produce electric field in this manner. Some are vibrating, so produce electric field in this manner. So as a result, when these group of atoms are vibrating due to the electric field, so their vibrations are different. Some are vibrating horizontally, some are vibrating vertically, some are vibrating at a certain angle to the horizontal. So when these radiations are produced, what we receive a group of radiation which is having multiple planes of vibration. When the group of radiation which is having multiple planes of vibration, what we call that as unpolarized light. The term unpolarized light means the light which is having multiple planes of vibration. Like multiple electric fields are there, multiple direction the electric field vibration happen. Some vertically, some horizontally, some diagonal, some inclined. So what is the meaning of the term polarization? The term polarization means when we convert this unpolarized light to a polarized light, like example, we remove all the component except one, what we call this process, we call that as polarization. So polarization actually means when we remove the components and just allow one to be there. So this is called unpolarized light and this is called polarized light. So how a light can be polarized? There are different ways to polarize the light. One is by using the polarizing filter. Another one is by reflection. Two methods are used to polarize the light. So one is by using a polarizing filter. Let's take, so this is an unpolarized light. When I say unpolarized light, it means it has many component of electric field vibrations. This is an unpolarized light. Means the vibration of electric field is in multiple planes. When it passes through the polarizing filter usually are crystals which are having a definite arrangement of the atoms. So what will happen when this unpolarized light passes through this polarizing filter? The polarizing filter, the atoms which are present in the polarizing filter absorb them, and these atoms start to vibrate, but they will vibrate only in one way. So when they vibrate only in one pattern after absorbing all, so as a result, when the light is produced, that light will have only one component. So this is the unpolarized light, and this one is a polarized light. So light which is having only one component of the vibration, when it passes through, We call that as polarized light. So how it can be done? We have an unpolarized light. We pass this unpolarized light through a crystal or a material which is having a definite structure so that it will absorb the radiation and it only vibrate in one plane. So when it will vibrate only in one plane, this will produce a polarized light. But because we cannot see the vibration, we can only see the effect. So the unpolarized light appear to be much bright because it has many component of vibration. But the polarized light appear to be dim because it has only one component. It only allow one component to pass. Rest all of them are being absorbed. What is the best application of the polarization? For the polarization, we use the sunglasses. The sunglasses are actually the polarizing filter. When you are observing the sun, like the light from the sun, it is high intensity. But when you are wearing the sunglasses, it appear to be low in intensity. So what actually happen is it is absorbing all the component and only allowing one to pass through. It is either electric field or magnetic field. Any one of them we are taking. These are all electric fields I'm saying. I'm not drawing magnetic fields here. There will be magnetic fields as well, but we are only drawing electric field. These all are electric fields. Because the source which produce these electric field, the atoms are vibrating in different planes. So when the atoms are vibrating in different planes, it produce electric field in multiple vibration or planes. But when it passes through the polarizing filter, it has only one component of vibration. Is it clear? The concept of the polarization? But what if I rotate this polarizing filter? What if I rotate this polarizing filter? And we have a polarizing filter which is like this was horizontal polarized. Now we place another polarizing filter which is vertical polarized. Vertical polarized means allow the vertical component to pass. Like atoms can only vibrate in a vertical plane. So as a result, what will happen? The light which pass through, it will only be vertical polarized. So it depends on the plane of the polarizing filter. If the plane of the polarizing filter is vertical, then the vertical component is passing. If I make a slightly angle, then the component which is, so always the component of the electromagnetic radiation or the transverse wave which is parallel to the plane of the polarizing filter will pass through. So as you can see here, this is example of the unpolarized light, which is having multiple component of the vibration. This is only electric field. We did not draw the magnetic field. Like here, electric field vibration in this manner. And when it is one component, it is a polarized light. And the polarization, as I mentioned, can happen or occur by two ways. One is through the polarizing filter. Another one is by reflection as well. Reflection and refraction is the same idea because say we have this is the unpolarized light. We just drew two of them instead of drawing all. So it is having multiple component of the vibration. But when it strike the surface, the component which is parallel to the surface, that is only reflected. Rest all of them are being absorbed. So what we call that as a polarization. So this is an unpolarized light. It strike and bounce back. So the component will be absorbed, and which component are able to pass through, which are parallel to the reflecting surface. Usually the light which is uh, reflected is not 100% polarized, it is partially polarized. Like small proportion is polarized. Some components are still there. So some components are still there. So when the light strike, it bounce back. This component of the light, this component of the wave, which is parallel, it's there. So we call that as a partial polarization. So we have like, for example, this is a light source which is having multiple component of the vibration. We place a polarizer. The first polarizing filter we call polarizer, and the second polarizing filter is analyzer. These are the scientific term used for them. So first we, like example, these are vertical planes. The polarizing filter and analyzer, both are vertical planes. So they allow the vertical component to pass. But if I rotate the analyzer 90-degree, like the polarizer is vertical plane and the analyzer is horizontal plane, in that case, we'll not see any light. So no light is able to pass through. Because the polarizing filter, the polarized light does not have a horizontal component. It only allows the horizontal component to pass. It does not allow vertical component to pass. So it will absorb all the light. So when a person is observing from here, he will not observe anything. There will be no light. So if we sketch a graph between the angle between the polarizer and the analyzer, so this is a polarizer and this one is analyzer. We have unpolarized light, and let's say the polarizer is horizontal polarized, means it only allow horizontal component to pass, and analyzer is also horizontal polarized. So which component of the light will pass through? The horizontal component of the light will pass through the polarizer. Which component will pass through the analyzer? The analyzer also horizontal component. So if we sketch a graph for the angle between the polarizer and the analyzer and the intensity of the light we receive. So when the angle is zero, we receive the maximum intensity. Now, if we rotate these filters, we have the polarizer, which is horizontal, the plane, and the analyzer is vertical. Now what will happen? The analyzer can only allow the vertical components to pass through. The polarizer only allow the horizontal components to pass through. So this horizontal it will allow. But what happened? There is no vertical component which can pass through. So as a result, when a person is observing from here, he will not receive any light. So there will be no light. So as a result, the intensity of the radiation, when the angle is 90-degree, when the angle is 90-degree, the intensity of a radiation will decrease to zero. When again angle is 180, like they're parallel, so the intensity of radiation increase to zero. So the intensity of a radiation changes as the angle between the polarizer and the analyzer changes. Is it clear about no light when the analyzer and the polarizer are 90-degree to each other? They're planes. There's a formula which we can use, that is the Malus law, that is the relation between the intensity of a light which passes through a polarizing filter, that the intensity of the radiation which is passing through the polarizing filter and the analyzer, or when we are observing that, that is equals to I naught cos theta square or cos square theta. What cos square theta means, like you will take an angle then square that. That's why, like we can write like cos theta square. That's also fine, or it can also be written as cos square theta. But don't write like this cos theta and then square. That is wrong. Either you put a bracket or you write cos square theta, because cos theta square means first the theta should be square and then take a cosine. That is wrong. So it should be cosine theta whole square or cos theta square. Now, what does it means? To know the value of the intensity of a radiation which passes through the polarizer or the analyzer. Like example, say this is a polarizer, which is example vertical, and this is a polarized light. The intensity of the light, like how intense it is, how much energy is on unit area in 1 second, that is the intensity of a light. Example is I naught. Okay. And we want to find what will the intensity of this, the light which passes through, in terms of value we need. So what is the relation between the intensity of the light incident and the intensity of the light which transmitted? The formula is I equals I naught cosine theta square. What is theta here? Theta is the angle between the plane of the polarizer and the incident light. So what is the angle between them? What is the angle between the plane of the polarizing filter and the polarized light? What is the angle between them? It is zero because they are parallel to each other. So means it is zero. So it means when angle is zero, so what I will substitute, I is equals to I naught cos zero square. What is cosine zero? Cosine zero is 1. So this will be 1 square. So what does it mean? I is equals to I naught. It means when the plane of the polarizing filter and the polarized light, they are exactly parallel to each other, or the angle between them is zero. It means the maximum amount of the radiation will pass through, or the intensity of the incident wave will be equal to intensity of the polarized wave. Is it clear? Is it clear, the relation between the intensities? Any doubt? Yeah, when the plane of the polarizing filter and the intensity, like the plane of the polarizing filter and the light, polarized light, they're parallel or the angle is zero. In that case, we have the maximum. But when it is perpendicular, so this is a polarizing filter and the plane of the polarizing filter, so it is horizontal and the light incident is vertical. So what is the angle between them? The angle, the theta between them is 90 degree. So we have the formula I equals I naught cosine 90 whole square. What is cosine 90? That is equals to 0. So 0 multiplied by anything, we get 0. So what is the intensity of the light? Intensity of the light will be 0 or there will be no light. So light is not able to pass through this polarizing filter. So as you can see, two images, one is on the right hand side, another one is left hand side. Which one you think is taken by the polarizing filter, by use of the polarizing filter? Left or right? Which image is taken by using a polarizing filter? Which part of the image? Left or the right? So the right hand side is taken by the polarizing filter, because if you compare the intensity, the simple way, you don't have to see too much. You just have to compare intensity, which appear to be bright. This appear to be bright. This appear to be dark. It means that this is taken by the polarizing filter, because polarizing filters reduce or like absorb all and only allow one component to pass through. So the image captured by using a polarizing filter usually are sharp images in that sense that does not have all the components, they have only one component, and it is relatively dim or dark as compared to the unpolarized. Sunglasses are polarizers. So how the sunglasses work, like example, see, two images are there. One is by using a polarizer. The image is captured by using a polarizer. Another one is without a polarizer. So what actually happened? Look, the light first without the glasses. If we don't use the glasses, now what will happen? Without the glasses, the light which is coming from the sun is an unpolarized light, which has having multiple component of vibration. The light which is reflected, it is horizontal, partially horizontal polarized. And the light which is refracted, it is vertically polarized. So as a result, what will happen when a person is looking from, like without the sunglasses, when the person is looking, he is receiving the horizontal component of the light, which is showing the reflection from the water surface, and he is receiving the vertical component of the light, which is showing the refraction. So as a result, what will happen? It will appear like this, that there is a reflection from the surface, and some part we can see what is underwater as well. Because two things are happening. The light is reflected from the sun, reflected from the water surface and reaching our eye, which is a horizontal, and some of the light which is reflected from underwater, it is vertical polarized. So as a result of horizontal and vertical polarized, we are able to see both images, like some reflection, some refraction. But when we use the sunglasses are actually the polarizing glasses. So as a result, what will happen? The sunglasses are actually vertical polarized. So when it is vertical polarized, so when the component of the light which is horizontal polarized, that will be blocked by the sunglasses. And the component of the light which is vertical polarized is able to pass through the, which is parallel to the surface of the like the polarizing filter. So the vertical component we are able to detect, the horizontal is blocked. So as a result, we'll not see any reflection on the surface. We'll only observe what is underwater. That's what happened. That is what happened in this image. You can see here we were observing reflection and refraction both. And it was not clear to us because the reflection and refraction both are happening. But when we use the glasses, the sunglasses, it absorbs the reflection from the surface. So we are able to see what is under water. Is it clear? This example about the polarizing filter? Anyone having a doubt or a question in this? So the Mallet's law, the same idea as just I mentioned, like if you want to find how much intensity of a light is passing through the analyzer, So the angle between the polarizing filter and the incident light, that is theta or phi. So I equals I naught cosine theta square. You can use that to work out. Just I give an application as well. You just substitute the value for theta and you'll get the answer. Analyzer is also another polarizer. The first polarizer, the first polarizer is definitely, because if unpolarized light is there, so first polarizer will allow the light to pass through. So when the Malus law is actually what intensity of the polarized light will pass through the analyzer. I cannot apply a Malus law here, the Malus law here, because it's obvious that light will pass through. So it is only applicable when we have a polarized light and the polarized light is passing through the filter. What intensity of the light will pass through that? That is using the formula I equals I naught cosine theta square, cosine square theta. So this intensity is I naught, this intensity is I. So how we relate them? We relate I equals I naught. You can substitute cos theta whole square, that's also fine. So theta or phi, what is here it's shown phi, but it can be theta as well. It's angle between the polarizing filter and the polarized light. It is used to find what intensity of a light will pass through the analyzer. That's it. So this was polarization. Anyone having a doubt or a question about the polarization, electromagnetic waves and the properties? Any question or doubt?